GHX. Now I'm going to present number 15, pancake rotation. Okay. In this experiment, we place a few balls in a round container. If you move the container around the vertical axis, the balls can move like round with the movement of the container. And they can move in the opposite. If you put a lot of balls in the container, they may move of the opposite side. I'm going to explain this phenomenon and investigate how the direction of movement depends on relevant parameters. So, what is pancake rotation? Pancake rotation is a term used to describe a specific type of rotational motion in which an object, typically a disk or a sphere, rotates around its axis while also spinning around a perpendicular axis. The motion is often described as resembling a pancake being flipped in the air, as the object appears to roll or spin around two different axes. So let's see what actually happens. In the video on the left side, we see only a few balls will rotate clockwise when the container rotates clockwise. So they're the same direction. And here, if you put a lot of balls in the container, this side will be, the direction will be opposite with the container. So in short, a few balls will rotate in the same direction as the container. Well, however, a lot of balls in the container will counter-rotate. This is the outline. I will talk about the theory, experiment, then discussion, and conclusion. Okay, first is the theory. Put some balls in a circular container and rotate the container around the axis. Since the number of balls in the container is small, the particles shows the properties of liquid like small friction, and the balls inside will follow the container, move in the direction of rotation. On the contrary, if you add more balls, the sphere behaves properties like high friction, and the balls will move in the opposite direction. Okay. This is the experiment setup. This is the base that can move clockwise, and the container and balls. First, the variation is different numbers of beads. We use container radius. The container radius we use is 9 centimeters, and bead radius is 0.3 centimeters. And rotation velocity is fixed at 9.24 centimeters per second. Bead number, we put 50 and 60, 70, 80, 90, 100 to 120 balls in the container. And we found out that when the number of beads is larger than 60, the beads will counter-rotate. So if you put 50 balls in a container, and the container rotates clockwise, the piece will rotate clockwise too. However, if you put more than 60 balls in the container and the container rotates clockwise, the balls will contain clockwise. And the second variable is different radius of container. Well, this time we fix the bead number. And in small container, we use 30, 40, 50, 60, 70, 80, and 90. And in large container, we use 50, 60, 70, 80, 90, 100 to 120 balls. The bead radius we use is small one, 0.3 centimeter. And the rotation velocity is fixed as the last one, 9.24 centimeters per second. Container radius is the independent variables. In this experiment, we use 7 centimeters and 9 centimeters. And we found out that in small container, when the number of the beads is larger than 70, the beads counter-rotate. In the large container, when the numbers of the beads is larger than 60, it will counter-rotate. So, in short, in a small container, you need to put up to over 70 numbers of beads. So that will counter-rotate. And if you use larger container, the beads you maybe only need 60 to counter-rotate. So the third variable is radius of bead. Container radius we fix as 9 centimeters. And bead number, small bead we use 90 to 130. And medium bead for 20 to 70. Large bead to 10, 15, 20, 25, and 30. And rotation velocity is also fixed as 9.24 centimeters per second. And now bead radius we, as the independent variable, we fix as 2 millimeters, 4 mm, and 6 mm. And for small bead, 2 mm, when the number of the bead is larger than 100, the beads will counter-rotate. And for the medium beads, when the number is larger than only 70, the beads will counter-rotate. And for the biggest one, 6 mm, when the number of the bead is larger than 35, the beads will counter-rotate. So these two are conclusion. Well, in a small container, when the number of the bead is larger than 70, the bead will counter-rotate, and in a large container, when the numbers of the bead is larger than 60, the bead will counter-rotate. And for the small beads, medium beads, and large beads, the number of the beads has to be more than 170 and 35. So smaller container needs need more beads, and with larger container needs less beads. about the radius of the bead, for the small beads, the number needs to be bigger. And if the bead is larger, like 6 cm, maybe you just need 35 beads to make them counter-rotate. Okay, that's.
Do you observe the initial conditions? Let's start with.
Pardon?
Do you observe the false start move?
Yeah.
Okay, and do you think it's a kind of the uniform circular motion?
Yeah, kind of.
Okay. And do you think it will affect by the simple harmonic motion?
Yeah, simple harmonic motion.
Okay, and do you think the experiment also has the transition zone, just between the co-diversion and the offset?
Maybe. So.
Okay. And what's the main cause in this experiment?
Main cause is as I said, is radius of beads and container and numbers of beads.
What force? The main force.
The main force is
Okay, if you do the experiment and you have the data.
Yeah, the data is I didn't show you on the PPs.
Okay, and do you think it will have the friction?
Yeah. So what do you want to ask?
Yes. And do you think it has the centripetal force or the centrifugal force?
The centrifugal force.
Pardon?
Pardon?
Centripetal force or the centrifugal force?
Centripetal force.
Okay. And your container is the same material?
Yeah.
Okay. That's my question. Thank you.
For the near 3 minutes.
second statement is we just and the boat can move direction with the movement of the container, or they can move in the opposite direction. And our main focus is the motion in this experiment and how does the parameter affect the frequency and angular velocity. And it's an overview of the report. The phenomenon is a clockwise rotation and a reverse rotation. And the theory is the particle numbers become bigger and the friction force will become bigger. And the experiment is the number of particles, rotational radius, and different radius of depth. And the conclusion is the number. The conclusion is the number of the particles can cause in different motion. And rotational radius bigger, frequency bigger, and the rotation of it will be observed. And the advantage is explain the experiment clear. And the suggestion is can put the picture to explain the theory. And need to analyze the force more. Need to put the experiment data in the PowerPoint. And need to explain the theory clear. And the words is too small to read. Need to put the bigger words. And it's the points to be discussed. The theory about the friction force, centrifugal force, centripetal force, and the colorious force. And then the experiment about the materials of the container and the particles, and how the rotational radius affect the rotation frequency, and different radius of things. And the accuracy is they don't have the data, and they need to do the force analysis. And thank you for your attention. And I want to discuss with the reporter. Can you explain your setup again?
Setup?
Yeah.
So with this machine as the base will this is the base that will rotate clockwise, and this one we use plastic container and we put balls in it. And like I said, if you put just some balls in the container, it will rotate by just at the same direction as the machine. And if you
Does this machine can control the speed?
no, I use the fixed speed.
Fixed.
Yeah. The speed is the same.
Also same.
Yeah.
Okay. And this container is stick on this machine, or it just put on it?
We stick on this so the container won't move.
Okay. Great. And then can you draw the force analysis to me?
Yeah.
Yes. Thank you. This is the container, right?
Yeah.
And it will rotation like this. Rotation like this.
You mean the beam?
No, the container. It will rotation
It will just like a container
and do this rotation, right? Yes. So can you analyze the whole system, not just the container? Yes. Like this picture is the flat of like this. And the turn it like this.
It's flat.
Yes, this is flat, and I turn it like this. This is like this. So when we view this flat, and can you explain the friction and the collision force? Quick. When it is rotation like this direction, and the friction force will like this.
Yeah.
And the material of this ball and this ball is the same.
Yes. All the balls in the container is
Okay. And so when you move like this, do you think it will have the collision force? Collision force. Collision force. Also, where is it? When it moves like this, and the collision force will like this. Okay, I agree with you. And then when you observe it, where is your view? Just like you is inside the container, or you just outside the container?
my view.
Yes.
I just inside the
Also, where is your angle? Just like because if you have the centrifugal force, if the non-inertial coordinate system, so you need to stand into the, just put yourself into the container, right?
Yeah.
So you just put yourself in the container.
Observe just right on the container.
You observe, you stand outside and observe it.
Yeah.
But it will like the inertial coordinate system. So the force will become the centripetal force, not the centrifugal force. Do you agree? Okay. Okay. Just like non-inertial coordinate system is that you stand into the container and then you observe it.
Oh yeah.
So you just like this, you observe like you stand in the container. Okay, thank you. And then because it will rotate like this, where is the centrifugal force? This is the center of this container, and the centrifugal force will like this, right? Okay, I agree with you. And then just now you think is the simple harmonic motion, right? And can you explain what is the simple harmonic motion?
Simple harmonic motion.
Yes.
Okay. When this one of the thing rotates by circle. One and this one.
Just like this. It will rotate. It will rotate like this to this side and this side and this side and this side, right? So you think this experiment is like a simple harmonic motion? No?
as you said, well, not really because
Okay, I agree with you. And then, in your experiment, you control the speed and control the material, right?
yeah.
And you think it will affect to the experiment?
Well, the speed, well, it may affect the it may affect the materials, I don't think.
So,
Because the factors is like radius and number, so it's not nothing about
okay, thank you. And in this experiment, you observe the transition. Yes, transition zone.
yeah,
Where's the range? Transition zone just between the co-direction and the outside. So, what's the range of the Gauss number? Sorry, the transition zone is between the co-direction and the outside. So where does the range of the amount of the balls?
so the amount of balls here would be like 17. Well, which one?
The number of the balls.
The number of balls would be like depends on the bead. Well, if you like I said, if you use smaller beads, the number of the
But do you control the beads and do the number of the balls?
yes.
And please turn to that page. And you just say you observe the co-direction and the upside, right? And you observe the transition zone just like two direction in both of it is axis.
Yeah.
So what's the range of it?
The range of it is just between about 55 to 60.
Okay, thank you. And you observe the stop, just the stop. And what's the range of it? Just over what's number?
Okay, time is up.
Okay.
Gentlemen, come to 1 minute to summarize the discussion.
And the summary of discussion, I'm very sorry that the presentation has some problem at that. And from the discussion with the reporter, we analyze the force and we both think the Coriolis force will affect the experiment. And the reporter didn't stand in different positions to analyze the force, and it may cause the centripetal force and the centrifugal force. And we discussed the setup of the experiment, and then their machine of angular velocity is the same. And then we clarify the simple harmonic motion, and the notation is not a simple harmonic motion. Okay, thank you for your attention.
Okay, reviewer, you have 3 minutes to ask questions to both sides.
Okay. The page in front of the conclusion. Your data is 10, 20, and 30, but your result is 35.
Sorry, I missed the 35 on my
Yes. Okay. As reported, do you consider a correlation between the balls? Do you consider a correlation between the balls?
well, no, not
do you think it will affect the motion?
Yes.
Okay. Next question. Report of what kind of friction between balls and wall of container.
Oh, what kind of friction between walls and container?
Yes.
Oh, friction you mean?
It's connected friction or silent friction.
Oh, connected friction.
Okay.
And when we stand in the container, and it will have the centrifugal force and the colloidal force and the friction.
Okay. Do you think the angular velocity of container will affect
The angle of
angular velocity?
velocity. Not really.
Opponent, do you think the angular velocity will affect the motion?
Yes.
Okay, next question. Do you think your container is putting on your plate is fine because you don't mount it?
Yes.
So do you think it will move while you are rotating the container?
Rotating the container.
Yes.
No, I just said I leave the container on place, so it won't really.
Okay. Opponent, do you think the reporter's setup is fine?
Yes, because she said she sleep on it.
Okay. Yes. Do you think your experiment data is enough? Because we only see the 10, 20, 30, but it will be 25 or 26.
Okay, I admit it, but that won't really, it won't really impact.
Yes. Do you think her data is enough?
Or I think she should put more data.
Yes. Reporter, do you think there is transition zone between the direction motion and opposite direction motion?
Answer. So reporter and reviewer, you have 2 minutes to prepare for your review.
Hello everyone, I'm a reviewer from the faculty and I'm Zheng Bochen. Okay, this is the problem statement. We think the reporter doesn't show the key points and highlight in the problem statement. Okay, it's reporter's pros and cons. Reporters well explanation of the phenomenon of words and great notation, but its experience data is isn't enough. and lack of explain of theory, no graphs, and no comparison of the different parameters. And the opponent's pros, the clearly indicate the pros and cons of the reporter, and great discussion on the blackboard in her theory. Okay, it's PF questions. Okay, opponent asks, do you think the balls will rotate in the UCF motion? And the reporter said yes, but we don't think it's UCF. We think it's like the motions like this. This is the ball, and it will rotate like this. Okay. And next question, opponent says, do you think it will affect by SHM? And reporter say yes. The reviewer thinks the reporter should discussion about the balls analyzed, and we don't think it's SHM either, because on the graph board is not the SHM. Okay. Opponent says, do you consider initial conditions? Reporter say yes. We think the reporters need more explanation. Next question, the opponent says, do you observe the transition zone? And what's the range of it? A reporter says yes. We think the reporter gets more data and get the limitation. Okay, this is a reverse question. The data is from 10, 20, and 30, but you said 35. The reporter says it's mistype. Okay, do you consider collision between the balls? Now, yes. Opponent says yes. Reporter says no. What kind of friction is between the balls and the board of the container? The opponent says the opponent didn't answer directly, and reporter says it's static friction. Do you think the angular velocity will affect the motion? And both of them say yes. Do you think putting the container on the motor is fine? And both of them say yes. Do you think the data is enough? The opponent says she should put more data in the result. And reporter say yes. Okay, thanks. It's my presentation.
Okay, the reporter, 2 minutes to conclude for your concluding remark.
So rotation of the pancake is due to the kinetic friction because it moves over time on the plate. It's not caused by the single harmonic motion actually, because while using tracker, the rules of either x-axis or y-axis is not a straight line. And we then consider the initial condition, including the real-time movements of pancake rotation, and we quantify our data. And then actually, I measured like, I just said 55 to 65, and we use that the data like over 70, maybe 71 and 69 with all measured. Yeah. And then 5S range, when we see the transition zone, we use 1S range, so the data will be accurate. Thank
told us today, if you had more time, what would you do to improve your reports?
If I have more time, maybe I'll just measure more about. I'll use graphic to quantify the data and measure by the more accurate number or radius.
Okay. What about the opponent? What do you think the reporter should have done? The most important point.
I think she should put more data in her PowerPoint and she need to explain that. And then she should do the force analysis in detail because she didn't do that.
Thank you. How about you?
I think if she had more time, she should get a clear limitation of the co-directionary motion and the opposite directionary motion. And she should compare with the results of that and even draw the chart of it. Yes.
Draw the charts of what?
Chart of the what condition will the co-directional motion will happen in what condition the opposite motion will happen.
Okay, thank you.
Other questions from the group, please?
Okay, I have a question for three of you. What kind of suggestions would you give to the reporter to do her data analysis? Can you do the first?
Her data analysis.
Yes.
Maybe-
What kind of suggestion? Yes. How to
Maybe
make it?
when she do an experiment about the radius of it or the number of it, she should radius of the container. She do that experiment, and she should put the experiment data on her PowerPoint so we can know what's going on with this. And she also maybe she also need to use a range, a lot of range, just like because she just show the co-direction and the opposite direction, but she don't show the transition zone and the slope. So we think she should do more experiments like this and more data.
Try to make it shorter.
Thank you.
I think it can use the tracker graph and we can compare with the radius of the balls and whether it move conditionally or opposite directionally.
Oh, tracker. Then you, if you would like to do your data analysis, what will you do? Yes, the same question. If you have the time to do your data analysis, what will you do?
Data analysis, I'll choose to use tracker to track the rotation of the balls to get a more accurate graph.
You'll use tracker.
And maybe draw some charts.
Thank you.
Other questions? No? Okay, if no more questions, then please conclude the grades. 6, 5, 5. Okay, not too much variation because we don't need any explanation on this. And the score for the opponent. 6, 7, 7, 7, 8. Yeah. Okay. And the score for the reviewer. 5, 6, 7, 7, 7. Okay. We don't have a large variation here. So I guess it's not required to offer any explanation. But if you would like to have comments, Amir, and the opponent is, how do you pronounce it? Vicaris. Okay. Reviewer is, we're family. Wow, we are family. Okay. Good. Now, the opponent, you have 1 minute to challenge the reporter.
Okay, team amateur, I would like to challenge problem number 12, the rice kettle.
Problem number 12. The reporter has 1 minute to decide.
We accept it.
Accepted? Okay, problem accepted. Now you have 5 minutes to prepare. And in the meantime, please write down the names of the representatives.
distortion in fountain meter. Today I will report is problem number 12 bicycle bell. And this is the problem statement. Take a vessel and throw some granular materials into it. For example, rice. If you dip, for example, a spoon into it and a certain depth of immersion, you can dip the vessel and content by holding the spoon. Explain this phenomenon and explore the relevant parameter of the system. So our main focus is study the force exercise for different systems and explain how the stick friction coefficient and the radius of stick affect the maximum stick friction force. And this is our experiment video. So you can see when we lift the stick, the all system will be lift up. So I will divide this system to 4 parts. First, we for a stick. When we pull the stick, it has the 4 force ampere, and it affected by the weight. And when the stick takes away from the vessel, it has the friction force. Its rise gives stick. First, we analyze the rise because of the content force. So they have the friction force is stick to give rise, and the normal force is the same, and also affected by the weight. And because the rise is not smooth, so they have the friction is vessel give rise. Second, we use for vessel, and also because of the counter force. So they have the friction is rise in vessel and also affected by the weight. And finally, we combine the all systems. For formula, dark blue, light blue one friction will offset, and dark blue one friction will offset too. So for all formula, we can get the first 4 friction is equal the weight of stick and the rise and vessel. This is our theory part. The silo effect, it means when we increase the depth of immersion, the pressures are not changed. So when the stick immersion of the immersion deep, so they have we enlarge it. So it have an effect by the friction force and the pressures of Z, and the pressures and the sigma R and the weight. And sigma R is the transfer press, and the pressures of Z is the longitudinal pressure. And rho is all the pressures. And when the friction force at the side A is maxima, the sigma R is equal to Kp, and K is a string consistent, and it means can change their direction of the pressures. And the 2 formula, it means the resultant force of all systems is 0. So we can get the pressures of Z here. So when we get the pressures of Z, we can focus on this square. The E is the zero number, is a constant. And when the Z equals 3 lambdas, so the E is a very close 1. So you can see very close 1. And when the Z is smaller than lambda, the pressure is almost a low GV. And it means when the depth is immersion, the pressure is also immersion, and just like a flow. And when the Z is bigger than 3 lambdas, the pressure is almost a low G3 lambdas. And it means when the depth of immersion is increased, the pressure is not increased anymore. So you can see it's just like a red body. And secondly, we to change to the normal force of silo effect. And because the rise is too small, so first we use the dN to equal sigma R and dA. And to find the all normal force, we use this. And sigma R is Kp, and dA is 2 pi R dz, and dA is the surface area. So So by here formula, we can get the normal force is here. And when we get the normal force, we also focus on this square. When the z is smaller than lambda, normal force becomes this. And the blue one is log z is a pressure. And the red is a 2 pi r z. And so we can know it is z squared, just like this one. And when the z is bigger than 3 lambda, the normal force becomes here. And log 3 lambda is the maximum of the pressure. So we can see it is a constant. And the 2 pi r3z also is a surface area. So we can gather this line. And this is our experiment setup. First, we use the force measurement. Second, we use the Pascal data to correct the data. Third, we use the phone to correct the data graph. And when we correct data graph, when we leave the vessel, and when you put down and take away from the stick at the moment, we can know this one is a maximum stack friction. And because our friction measurement is measure the pressure, so it is minus. And first, we change the depth of immersion. And when we change and for this graph, x-axis is the depth of immersion, y-axis is the maximum stack friction. So when the depth of immersion increase, the maximum stack also increase. And because this one is between the lambda and 2 lambda, so it is not any parabola. And we change the y-axis is a normal force, and we can know the friction force increase. Because of this formula, we can know the friction force also increase. Second, we change the static friction coefficient. First, we must measure the static friction coefficient when we put some object at the slope at a certain depth, and it also be affected by the weight and normal force and the friction. So we can get the mu x is a tangent theta. And this is our static friction coefficient. And for this one, the x-axis is a static friction coefficient. Y-axis is a maximum static friction. So when the static friction coefficient increase, because of this formula, we can know the maximum static friction also increase. And this graph is to combine the depth of immersion and the static friction coefficient. So we focus on this line. This line is mean the same coefficient. So you can see when the depth of immersion increase, the maximum static friction also increase. And this line, so we focus on this line. This line is mean the same depth of immersion. So you can see when the static friction coefficient increase, the maximum static friction also increase. Third, we change the radius of the stick. The manipulated variable is the radius of the stick, and we control the weight of ride, depth of immersion, and time of shaping, and coefficient of the stick. So first, for this graph, we change the radius. The x-axis is the radius of the stick. Y-axis is the maximum static friction. So you can see when the radius of the stick increase, the contact area also increase. It means the silo effect, the silo effect theory is the 2 pi r dz. So when the contact force increase, the maximum static friction also increase. So this is our conclusion. When the depth is bigger than 3 lambda, the pressure is not changed, and normal force proportional to the depth, and the part of load is a parabola, and the part of rigid body is a line. But we can see our data when it's between the lambda and 2 lambda, or between the lambda or 3 lambda, it is not the orbital and the line. And second, when the depth of immersion increase, the maximum static friction also increase. Third, when the static friction of the stick increase, the maximum static friction also increase. Next, when the radius of the stick increase, the maximum static friction also increase. And thank you for your attention.
Okay, so I'm a Pona from Typt, and I would like to ask some short questions. So first, what's the main parameter of your experiment?
Main parameter.
Yeah.
Main parameter. I
Your
think
answer, please. Your answer, please.
the depth of immersion.
And only that or you?
Yes.
Okay, so next question, so what is lambda? Because you didn't explain.
Lambda is a certain depth of immersion, just the depth.
Oh, okay. Also, did you consider arrangement of the rice?
Arrangement.
Arrangement.
What's arrangement?
Arrangement is like how do you, like, if this and this is different arrangements, this have up and down, this is.
Yes.
Did you consider it in your theory?
Yes.
Okay, so next question. So you say the transition force between lambda and 3 lambda is complex. So did you do approximation? Approximation. So did you know what is approximation?
Can you explain?
Oh, okay, we'll explain in the discussion section. And the next question, how many times of experiment do you do in each graph?
How many times?
Yes, of experiments.
In
In the same condition.
the same condition.
Yeah.
The time is mean what?
Did you do it 3 times or 5 times? Or?
5 times.
Okay, 5 times?
Yes.
Every group, okay, so next question. Did you consider rice as a ball or what? Or
No.
you didn't consider the shape?
No.
You,
I didn't consider rice as a ball.
okay, so, did you have a quantitative comparison between the theory and your experiment?
Yes.
Oh, okay.
Answer?
Oh, okay.
Okay. 3 minutes, so we know that to prepare for the assignment.
No?
now?
Okay, so I'm the opponent from Team Vipers, and I would like to take the floor for 4 minutes. Okay, let's start. So this is a problem statement. The reporter just clearly indicates that a certain depth of immersion is a key point, and the key point other is the force analysis. And this is a summary. And so the observation video clearly shows the phenomenon, but there's no cons in the observation video. And in the parameter discussion, the summary is that the reporter only discussed about the depths, but lack discussion of other parameters. So we will discuss it later. And but the parameters in the depth, the explanation is very clear. And in your theory part, the reporter did an excellent job of the force analysis and the Siddle effect, which is also persuaded. But the cons is that it didn't explain how the theory works on the experiment. Okay, so in the experiment, using the reporter used a Pascal measurement, so to measure the force, and which is a created setup. Yeah, but the axis isn't very clear. We will discuss it later too. And in the conclusion, the reporter only compared the theory in experiment qualitatively, but not quantitatively. Okay, so so I would like to ask some questions. We can start in the discussion section. First, you think that the pressure depth graph has a limitation, right? In page 7. Yeah. Yes. Okay. So could you give explanation about? Could you give a qualitative explanation of this phenomenon of the 1 minus exponential?
Just for two formula, get it. And the one is a constant, so don't focus on this word. We focus on the E.
Oh, okay. So, I would like to explain it qualitatively because that when you insert a rod, the right will be pushed to the each side up, and it will just press the rod, and so that's the reason that when the depth is increased, the pressure will also increase. But why there's a limitation is that because there's still when even if there's infinite depth, and there's still only limited right side can be pressed onto the east side. So I think this is the main reason.
But you think the pressure when the depth of immersion increase, the pressure also increase. But you think when the Z is the depth of immersion, when it is equal to 3 lambdas, the E exponential is almost the maximum, and they don't change. And it's a 0.3, 0.95, and just almost close to 1. So the pressure did not change.
Oh, okay. Let's see the formula explanation. Okay, very good. So in the next question, in page 8, just as you showed, I would like to ask why Z when Z is very small compared to lambda is like a fluid. Could you say why is like fluid, and why what's the difference between this and the fluid?
This is this one.
Oh no, I say not in your graph, in your in
and because the fluid is just when the Z is increased, and the P also increased.
yeah, that's the
And
fluid formula.
Yes,
right?
in the fluid, yes.
But what's the difference between the fluid and the rise pressure? You can't say that the fluid pressure is just same as the rise pressure. What's the main difference between them?
Different.
Yes, between the liquid pressure and rice pressure. Even if its formula is you can approximate as a fluid for rice.
Yes.
So how would you explain it, the difference?
You say the rice and fluid
Yeah.
different,
There's still some difference, right?
Yes.
What's the main difference?
but we just focus on the rice, the distance.
Okay. I think the main difference between the rice and the fluid is that the contact points on the rice is not continuous, but the fluid is. But in fluid it is. Right? But
You,
that's a great approximation.
you focus on the contact area.
Yeah, like when a rice, when in the rice pressure, like it's like many balls on this can. But in fluid, it's just like ants on the can. It's the contact area is continuous.
And
In the rice, it's not.
When the distance is low, the rice just very to move. So it's just like a fluid.
Okay, so. Okay, so in page 9, so I'm asking you the arrangement question, so let's go to the backbone. So, you say you consider the arrangement of the right and right?
Yes.
Yes, so how would you consider it in theory and your experiment? In different aspects, in the experimental aspect and the theory aspect. How would you consider the arrangement?
So this is the theory. So
Basically,
this is the
yeah.
theory.
yeah.
So when it is smaller than 3 lambda, it's just the parabola.
No, I'm not talking about that in page 10. I'm talking about in page 9. Your force analysis is right, the normal force, but maybe in. So if the arrangement is different, the direction of the normal force may not be like this. Like in this situation, the rise is like this. Yeah. So if we analyze we just consider the two rises here. We don't consider other parts. And the normal force, the direction will not be look like just horizontal to the plane, right? It will have.
Also attach this part. So
But the direction will be like this, right? Not as the vertical force.
yes.
And so if let's assume that the force is like this, not horizontal. Yeah. So if the total, the maximum, the summation of force is you need to get it on vector, right? So it should need some correction to the force, the total force.
For the formula, we don't consider the digression, just the all normal force. So
But you say you consider the arrangement. So
Oh.
where did you consider the arrangements in your theory? Arrangement is that.
no, we don't. This is my mistake.
So when you in my question section you just say you consider arrangement in your theory, but where is the arrangement?
It's just my mistake. We don't consider this one.
Oh, okay. So did you consider in further parts
No.
of your? Okay, that's okay. And that's the theory part. Okay, let's finish. And did you consider the experimental part?
Yes. Experimental is like
Like
this one.
huh? Sorry, please say your name. Where did you consider the arrangement? Arrangement?
No.
No, not in this chart. In other chart? No. So you didn't. As you know that the arrangement will cause some deviation of your your graph or data, right? So you didn't consider.
But we control the types of shaping. So we just let the arrangement to extend.
Oh, okay. So you consider it as a constant, right? You say you did 5 times of the experiment, and you in this 5 times that you just the average you just didn't consider the arrangement, and you consider it as a constant since you did many experiments. That's good. So I suggest that if you can consider arrangement, maybe your could you please review the graph yeah, so like this, the error between maximum and minimum is very big, right? So I suggest that if you consider arrangement or did more experiment, the error will be more small, and this graph will be more persuasive. Yeah. And you say that in lambda and 2 lambda in this graph, the depth of immersion and the pressure is not linear, right? The graph is not linear. So how would you, since that you know this is there's x 4 times, the 4 times of x. So can you did an approximation? Approximation is like so when like this is a function of x squared plus 0.0001. So when x is very big, like x is 2, so it will be 4. So this will be relatively larger than this. So you can make that that's an approximation when it's in some region. So did you did it in your graph, or did you consider it or think of it?
Because we only used to at 9. We only do the 9 times. So it just has a very big one.
Yeah.
But
Okay.
but if we do the more times, maybe this one can be the best. Cannot.
Okay. So. Okay, I got it. So maybe you should do more data to make greater the lines and maybe an approximation will appear, and this will solve any problem which will make your theory and your experiment fix better.
But our squares is very close to 1, so we think that just this number just we need to do many experiment, and they can be very just like a
Okay, I got it. So so how did you next question? So how did you measure the density of the rice? You measure the volume by the actual volume of rice, since that you know the arrangement is not perfect,
Yes.
or did you consider the continuous volume as when you're calculating your density?
We
You say you
calculate the
yeah.
density to use the mass to divide by the V, and we just with the
Oh no, I think you have some misunderstanding. The volume is the continuous volume of the rice volume.
rice.
Rice. Okay, so which did you think is better?
Rice.
Or okay, right. Thanks. So in our discussion, we discussed about the theory and the arrangement of rice, like the one on blackboard, and I suggest that the reporter, if the reporter can do some correction due to the arrangement of the rice, maybe the data and the theory will be more persuasive, and maybe she can connect the theory and experiment more closer. Yeah. So but the reporter says that the arrangement can be considered as a constant. But since there's still some error in many graphs, so I will suggest that maybe you can do it more precisely in your theory, or you can do many times in your experiments. And okay, so and maybe you should consider the density in both aspects. Okay, that's okay.
Now the reviewer, you have 3 minutes. Last question to both sides.
So for reporter, I want to ask, how do you know the accurate attachment of specific area of the stick? Attachment.
Attachment.
Yes. Just like what?
You want to know the contact area?
No, it's like, how do you know the specific area describes the whole stick?
Whole stick.
And so, how do you think you can consider the specific area of each stick, of the attachment of the stick and the rice?
If I will consider it as the reporter's representation, so I cannot do it because he didn't consider it right. But I would think that I would do much more experiments, much more data to ensure that the contact point can be considered or not.
So, can you measure the surface of the rice?
Surface of rice.
Yes.
And we measure it, but I think the real surface of rice is too hard to measure because they have some area on the vessel.
So, do you think the coefficient, the static coefficient you calculate is accurate? Because since you told us that you cannot you cannot measure the specific size of the rice, how do you know that the coefficient is?
We just use this one, and at a certain depth, we can find a formula, and we can know the coefficient.
So, did you think that in this, like, I think beyond that thing is the rice, right?
Yes,
And
right.
so, you measure the coefficient, but do you think that this coefficient can be included in any rice of this plate? Or this is just an average of the coefficient in this plate?
An average, I think.
Okay, so it's the average, and how do you know that this stick, that the coefficient is correct? Because in this part, like in each specific area, the coefficient will be different since that is the average of the coefficient.
We use the maximum friction coefficient. So the maximum is just only one.
I mean the coefficient is static, the static coefficient.
Yes.
Okay, time is up.
Okay.
Reviewer, you have 2 minutes to prepare.
statement is take a vessel and pour some granular material into it. For example, rice, and if we take each a spoon into it, then a
Hold on. Can you connect to the
So the main focus.
Hold on.
Yes. They focus on the static friction coefficient and radius of the stick, and the force analysis.
Okay, go on.
So, for the overview of the reporter, I think they explain the theory clearly and the chart is drawn clearly. And they have paired force analysis and use force attachment and use Pascal to set off. And the con is they need more data because I think 5 experiments isn't enough to test the average of the maximum friction. And they only discuss one parameter and didn't include how the theory works on the experiment and didn't consider the attachment between the stick and the rice. And they left the data to include it in a chart. So for the overview of the opponent, the pros are to consider the shape of the rice and to consider the limited attachment between stick and rice. For cons, they didn't summarize the conclusion and observation of the reporter and didn't consider further parameters, and they only disagree rather than discussing. So for me, I think the parameters will affect our radius of stick, depth of stick, roughness of the outer surface, which is the T. So they talk about phenomenon is more like fluid or rigid body. The report said that it is like fluid because they only focus on the distance, and I think this is not really related. And for the opponent, they said that the contact area isn't continuous, so it's more like rigid body. As for reviewer, I agree with the opponent because as the stick lifts, the grains around it become slightly less compressed, which can cause the arch structure to break down. Therefore, this phenomenon is more like rigid body. So I want to talk about the missing point. For reporter, they didn't consider the arrangement, and opponent, they didn't consider other parameters. And I want to talk more about my questions. So they didn't know the accurate attachment of specific area of the stick, and they answered the question which phenomenon is more like fluid or rigid body wrong, and they cannot measure the accurate size of the rice, but I think it can measure it if you put the rice in a surface and make sure the distance is lower enough, and to calculate the intensity of it, and then how did they know the data collect as the maximum friction? Since they only collect 5 data, so I think they need more data because when I was conducting this experiment, I did like 20 times because the arrangement of the maximum friction is actually really big because like the attachment of the rice and the stick each time is actually really different, and they didn't measure in which depth the stick couldn't afford the mass of the rice. And for attachment, okay, thank you.
And thanks opponent and reviewers advice. And this paragraph statement says it means that when we leave the vessel with the rice and the stick, it will have the best force. And from our analysis, we vote for 4 systems, and we finally can know the pulling force is all the weight. For the silo effect, we know when the dip is over the 3 lambda, the pressure and the normal force and the friction force will not change anymore. For the experiment, we change the depth of immersion and static friction force and the radius of stick. And when the contact area between the
stick and mesh increase, the friction force and normal force also increase. And from the discussion that I will put another parameter in my compound. And the opponent asked me what is the main parameter in the experiment. So I set the depth of immersion. And it's the main parameter. I don't discuss about another parameter. And because the problem statement lets me focus on the depth of immersion. So I think the main parameter is the depth of immersion. And for my mistake, I said we consider the arrangement, but we don't consider the arrangement of the rise. Because our arrangement it cannot control because they need to flow to the state. But we do the experiment every parameter 5 times and give the range to reduce the error. And the error bar in my chart is so small, so the data is very, very fit to the theory. And the reviewer said I just 5 times, and our data is 8 times, and 8 times we use the 5 times. So thank you.
And for the questions?
Question for the reporter. So you have this graph of a curve and some error bar. So curve is got theory or it's just the best bit of the experiment?
It's one error bar.
Okay. This one?
No, I mean the
Oh,
curve.
you mean
Did you
this,
derive the curve from the
This
theory?
curve, yeah.
Or it's the best fit to the experimental data?
It's experiment.
Oh, so do you have a
Fitting from the experiment.
do
Okay.
you have a comparison between your theory and experimental data?
No.
Okay.
Other questions? Yes, please.
Can you explain this again for the DS?
DS.
What's the DS?
DS.
Y-axis? Yeah.
It's
This
maximum
Y.
static friction.
Maximum static friction.
How do you measure the friction?
Maximum friction. When we let all the systems pick up and we just put them. Oh, if we put some object on this, and when take away from the vessel at the moment, we can know the maximum static friction. Just like this one.
Okay. And another question is, you say you do the experimental for 5 times, right?
Yes.
And the first time, is any different for every time for the ditch?
No, we don't change.
You don't change the ditch.
Same again for 5 times.
For 5 times, we don't change the dip.
So you fix the dips.
Yes.
And the dips, when you got the dips, you can dip all the system, right?
Yes.
Okay. Any comment or reviewer for this experimental?
So you use this force measurement because that means that the friction it pulls up is only the mass of the rice, or there's another force.
Yes.
It's not for discussion now. Okay.
Oh,
You just comment is
also for comment, I think she still needs more data, and as my conclusion, I think this setup actually needs to be adopted because as I can see that there is only one force down, which is the mass of the rice. And so I think the friction measure is only the rise of the friction, of the maximum static friction. So I think that is not really the accurate result of the friction.
Sorry, I can't talk.
No. For the comment. You comment for his,
I partially agree with that, but the report then explain more about the detail that they insert the rock. So, but I think to his explanation, I think so.
okay.
to the opponent, you mentioned many times about the arrangement of the rice. What would you suggest her to do to have this?
I think we should measure when she measure the rice, the coefficient of friction. The coefficient of friction, the mu x. But maybe I suggest that we can measure, and when we stick many rice together, maybe we can get the coefficient of multiple rice, and it will fit more to the theory.
Other questions?
A quick question for the
Okay.
reporter. How do you decide your error bars in your data?
How do they discuss?
Well, you just answer. Baseline.
What was your question again?
How do you decide your error
Oh,
bars?
decide. How did you decide your error bar?
You show the error bars
Yeah.
and how.
How did you get the error
How
bar?
do you get that?
When our data is not the same, so we got
There are 9 points.
yes, the 9 points.
Each point they have different error bars.
Yes, but
How did you get the error bar?
And how?
You just use the formula?
no, we use the Excel formula
Oh, Excel's formula? Okay.
and we can get this one. And the not error bar, it means our data is very credible.
Okay. Is it okay? Okay. I think time is up, so please finalize the score. Seven, seven, and 7. 0 error bar. And the score for the opponent, 6, 7, 8. And the score for the reviewer, 6, 7, 7. Okay? Not too much variation, so but if any comments, still welcome. Yeah? Okay, then let's conclude this one. The opponent, you have 1 minute to challenge the importance of problem.
Do you accept number 4 colored line?
Number 4, okay, and the reporter, you have 1 minute to decide.
Okay, the opponent would like to accept.
Okay, problem accepted. Number 4, colored line. The reporter has 5 minutes to prepare. In the meantime, please write down the names of your representatives on the board.
Hi Chris, and today I would like to present problem number 4, the color line. So this is the outline, just an introduction and observation, the theory, experiment, and the conclusion. Okay, so this is our problem statement. So when a compact disc or DVD is illuminated to a light coming from a filament length in such a way that only rays with large angles of incidence are selected, a clear green line can be observed. The color varies upon slightly changing the angles of the disc, and just explain this phenomenon. So the key point is that, so why is DVD and disc so special to produce the color line, right? And does it make only green line, or it makes, in fact, many colors of line? So this is our observation video. So we just changed the angles of CD, which we call it beta. So, and as you can see, there is many different lines as well. So, okay, so into our theory part, let's go to the basic concept first. So this is a diffraction. So the diffraction happens when a straight line when encounters an obstacle. So the propagation will just diffract it way like this. And the next one is the interference. So interference means the net effect of the combination or of two or more waves. It can be divided into constructive interference and collapsing interference. And so combine the diffraction and interference, we can get the diffraction gratings when a light is diffracted into several beams, and they interfere with each other, forming a dark and light image. So that's our basic concept of theory, and now we are go straight into the CD. So these are the diffraction gradients on the CD. So first I'm going to the tracks width is D. We call it A, and the next one we call it A of any of the tracks width, and the N is the numbers of track, and R0 and D just a constant. So the observer is at O, and this is the light source. And in order to calculate the wave more easily, we change the intensity into the form of E, which means electric field. In electric fields, propagation is this equation, E, and I means just imaginary number, and K is a constant, and the D equals to this because we just assume it here. So we just did a summation of the total number of tracks, and this is just a mathematical operation, and by the operation we can get these results. And since the light intensity is proportional to the square of the electric field, so we can get these formula according to this one. And the other theory is that assume n, just an integer, equals to a over lambda n cosine alpha, that a constructive interference occurs while the intensity just increases, obviously. So that's the line we see. So therefore, if we didn't consider the inclination of the CD, we just only consider the alpha, we can get this equation now of lambda equals to a over n cosine alpha. But the problem statement says that the we should consider the inclination of CD. So which we did a different mathematical operation, and we can get A cosine beta over M cosine alpha. So the theory is that lambda equals to this, and if we since A is a constant, just a DVD constant, so we only need to change beta and alpha, and if we can get the integer, M by measuring the number we get in experiments. So this is how our structures are made. So this S is just the license, and the O observer, which the observer is in connected to the spectrometer, and this is the CD plate, and the alpha is the angle between S and O, and the beta is the inclination of the disc. And so how we measure cosine alpha? We can measure by just measure the distance between each point, and beta is measurable by just calculating the angles by I don't know how to say it in English. That's okay. And A is just a constant, and in the DVD we use is 1,400 nanometers. So this is our setup. This is just a license, and we just have the light stream into the disc, and and the observer will collect the data, and the classical spectrometer will analyze the data and get the spectrum. One more thing is that we can change alpha by using a field to let it just be on different position, and beta can be measured by this, by rotating the rod, and we just measure the beta angle. So this is just a pure LED light intensity wavelength graph. Look like this. There is a blue peak here and green peak here, yellow peak, and goes into red peak, like over here. And this is just in the infrared region. So we call this as a background. So in our experiment, the background should be almost constant. So this is our first graph of A. We did a cosine alpha as 0.725, beta as 0.84, and this is the graph we get eventually. That there's a green peak here and blue peak here, and the red peak just keeps constant, and the background is almost corresponding to the LED. And so there are two peaks. One is here, and it's about 530 to 540 we measured. And in our theory, the lambda equals to 540 nanometers when m equals to 3. That's in the green region. And in m equals to 4, it gets 408, which is blue. Or blue, it's blue to the purple. And this is the second graph we get. So the blue line here, the main peak still looks the same, but there is the light blue peak here, which is about 460 nanometers we measured, and there is a red peak here. So the red peak here indicates the 680 to 690, which in theory our vertical prediction is 692, which is in red region. And for 461 nanometers, in this case the light blue. And so we didn't consider the when n equals to 1 or 4 because it's not in the visible region, so we just it is just not so important that we need to mention. So this is the third graph. Okay, so there is when we change the cosine beta slightly, when we change it from 0.8 to 2.39, and the lambda gets 682 when m equals to 1. Then when m equals to 2, it gets 341 in theoretic, right? So we predict that there is only one peak in the upper color line. So in fact, when we measure that the peak of the river gauge look like that, but the peak when consider this angles look like this, is the intensity just increased more efficiently. So there is only one peak and corresponds to our theoretical prediction. Okay, so the final is about the conclusion. Since there are many diffraction gratings on the surface of the CD or disc, so it forms a color line, and the light is reflected from the gradients to constructive interference to make various colors. And here the conclusion is that the light intensity gets larger when the condition of n and this is the vertical lambda formula, which is proved by the experiment.
Understand? We have 2 minutes. Ask 4 questions.
Okay, and as I mentioned, do you think the refraction is the main reason that we see the green line? The refraction.
Refraction, partial, but not all.
And how about scattering?
Scattering
Is one of the reasons?
Not the main reason we have considered.
Okay, and as I mentioned, you just say this and DVDs. Can you explain the difference between the CDs and DVDs?
They all form the color line, but the color is different when in same condition, since the difference track with like
Okay.
DVD.
Okay, the rainbow lights look like a triangular prism. And do you think they are the same phenomenon?
In what phenomenon?
The rainbow.
The rainbow.
Is the same reason? Okay, never mind. Okay, never mind. And did you in the problem statement say we have to find out the green line, but you didn't main focus on green line. Yes, green line.
So I think is that the problem statement is just generally conditioned. So if we so a red or a blue line can be formed because we just see it. But in general, when we look at the CDs, just as a green line.
And okay, when the angle is too big, and the reflection may influence the observation. How did you deal with it? The reflection from the light.
When what angle? Alpha or beta?
Beta.
Beta. I think you will be influenced, but
Thank you.
Three minutes.
from your family. And it's a problem statement when a compact disc or DVD is illuminated with light coming from a fluorescent lamp in such a way that only rays which right angles and incidents are selected. A flaring light can be observed. The color varies upon slightly changing the angle of the display, and investigate this phenomenon. Manifolds on the connection between the angle and the green line on the different CDs and DVDs. As the reporters pro, that they have a very clear theory about how the system works and therefore the theory. But they only use one disk. They didn't compare with other disks. Maybe different disks maybe have different phenomenon, and they go experiment and didn't focus on green light. And I have some more pros I want to say. They predict the experiment. I think it's good. And discussion, I think the theory, the importance of the theory, like how would this separate the light and diffraction grating and triangular prism? Because they look like they can separate the white light too. They can make it into rainbow, but they are different. And difference between CD and DVDs because they all can produce the green line, but I think the lightness and the angles may differ. So I think we can. And why we see the green light, they introduce it very clear. And the refraction and reflection and scattering is three phenomena of the light. They may be influence the experiment. So I want to discussion later. And how is the green light? These are variables like distance, this line CP and the line CH and the angles that may influence the experiment, and they explain it clearly. I think there are some control variable in this experiment, like the distance from the bulb to the disc and the light intensity. We have to control it, and the camera, the distance from the camera to the disc is also important. And I want to overview the report of the reporter. Let's say the key point is disc or DVD and various colors of light. But I think the purpose statement says we should focus on the green line more, but they talk about other lines more. I think, and they explain the diffraction, interference, and the refraction grating. Yeah. And they show a formula and explain it. Okay.
Want to move on to the next stage?
Okay. On to discussion. What's your formula like this? Right? Did you show a formula like this?
Yes.
And can you explain what it means?
I need to. Here, right? The graph converging. So first we need to focus on the rotation of this. So I say Z and R0 is the constant because like Z is when H appears to the center of the DVD. And since you know that in the middle of the Y region that there is no track, right? So we didn't consider the track. Sorry. We didn't think that it will have the color line form. So we just consider R0 as a constant because it will exist every time. And the A is the track width, which is 4,400 nanometers, and the M is just the integer or the numbers of tracks. And so, but this is the HP line, right? But the light it has experience is this. So this needs a sine alpha to just over it, and we can calculate the real.
Okay, our different P points we have different M.
Yeah, since all of Z are 0 and A is constant, am I right?
And when we have to observe the color line, there are many P points on it, and we have to plus their electric field.
Yeah.
Yes, and so how did you change this formula into this?
This.
Yes, how did you change this formula into this?
So let's talk about this. So because you know this is the electrical field, and you know that the electric field is a wave, right? And the wave propagation line. So you know that. So like the wave just propagating like many sine waves and cosine waves, right? But since as you can see in here, we just use only simple mathematical. This is just a mathematical operation, and if we use sine and cosine we just combine it and calculate this again. It will be much complex to calculate.
Thank you.
So okay.
Can you change the name, please?
This thing.
Yes, this A. Since the light intensity is proportional to yes, the
Where?
yeah, yes, and the energy of the wave is proportional to wavelength. It's your unit.
Could you explain more? Could you explain why you just write this formula
Like
according to what's on my
let's say
presentation?
light intensity. Expression to electric like this.
Yeah, because it's a vector or sometimes it's just
And this formula is because of this. Do you agree?
What units did you use for the energy of wave? What's the formula? Could you explain what's the formula between light intensity and energy of wave?
As we the light and in the air, the medium may move like it's similar with SHN. And
Okay, I know what you mean.
okay, and so the energy of wave is proportional to wavelength to do agree.
But you also consider the kinetic one, since I didn't consider the energy of this, but as your formula, you only consider the kinetic energy, right? So is it right? But if, I'm now 100% sure that your formula is right, but according to this.
Okay, now let's go to the
Oh,
next section.
yeah.
As I mentioned before, let's say the triangle prism also separates the light in rainbow.
Prism, yeah.
Light, and the diffraction grating also separates light.
Yeah, but
They are different.
so I'm going to explain the difference. So, I think that even the phenomenon looks similar, but their mechanism is not right. But it's not the same. So
Okay, so what is the main reason of the prism?
I think the refraction. Yeah, refraction means just bending.
Okay, as I mentioned, you only use one seat. Is this or DVD? Only use one.
We only use one type, but we have made sure that every time the surface is very clear.
Woo! Sorry. And okay, but what thing? Do you think the plain DVD and the burn DVD may different?
Blank DVD and burn. Since in my opinion, I think that burn DVD is just because DVD is the mechanisms that the track is different. So I think maybe in sometimes if the track is filled or so the track doesn't exist. I think in some situation it will be different. Okay.
Okay. So what I think burn and blank DVD are different because this is the blank DVD.
Yeah.
And refraction it looks like this.
Yes.
And it's a burn DVD. Okay, I'm going to burn it now.
Okay.
Yes. It's changed. So the refraction may be changed like this. So the color line may be different.
I think the phenomenon we have explained. If we just make the light just straight into the burn track, since some tracks not burn, I think the phenomenon will become more complex to observe, to research in theory and analysis by the spectrum we get, since there will be much complex interaction between maybe this case.
Okay, thank you. And can you explain me some difference between DVD and CD?
It's just the track with difference. I think most of it, just this phenomenon is we can say that only affects the track.
The DVD can store more, right? Store more, yes. Yes. Okay. And store more. Okay. I think the DVD reflection will brighter than CD. Do you agree? Yes, because.
Besides, it can store more, so the track.
Okay. This is a light. I put in this. And this is more. There is more surface we can reflect it, and more light we can reflect it. So a brighter DVD will bigger than CD. Do you agree?
To my intention, I think the wavelength is not.
No.
I think it's not very.
That must.
Okay.
Thank you.
Okay. 1 minute to summarize this session.
Okay, sorry. Okay, I discussed the DVD, CD and DVD is different, and the plain and burn DVD is different, and also talk about the theory formulas. And I want to our discussion with him. What is the first formula to the next film formula? They how to change it. I want to know, so we discuss it. Also we want to know the energy of wavelengths and the connection with the electric field. Yes, so we want to find it. That's what we said. Thank you.
Okay, reviewer, 3 minutes to ask questions.
Reported and how do you define the green in C? Have you used the spectrum or RGB or EIE?
Just like the spectrum, we have detect by the spectrum, and we just we have this in the color card and to compare it
you
and
have the range of the green.
what?
The green is a little bit yellow, a little bit blue, and you didn't have the range of the green.
Just as but green, but everyone's the
Thank
eye.
you. Okay, thank you. And please, what is the line under this that we can observe, but not a shape? It's a line, not a shape.
It's a line down the shape.
And why?
I didn't mention
Shape
the
is
shape.
the area.
Area. Oh, it means like this.
Yeah.
Okay, I think we should mention. We just mentioned the color. So the area. If the area to spread is not a line, right? So I think we should focus on the colored line,
Yeah. And why is the line not a plane?
not a plane, not a shape area.
Yeah.
Oh, because the problem statement say colored line.
Okay, and how do you think why and it will not from the thing?
I almost agree with what opponent has just said about.
I mean why it will not from the thing.
Just in our view, and you can see a light. Just.
Okay, and do you find
But
that
I cannot. But I cannot find the width of line, so I didn't know what your meaning of line. The comparison between the
okay,
other.
thank you. And do you find that at different view angles the line may be not be straight? You stand in different angle and see that you will not
So
be
you
straight.
say you're talking about just half of the
The
line.
line will be not straight. You stand in a different angle and see.
In fact, I don't know.
Okay, and how do you think?
How do you say? To say this
You stand in a different angle and
different angle and I watch a different line.
if you and you will see the not straight line.
Not straight line.
Well, yes or no?
I see no.
No. Okay. Thank you.
I mean no, it's on the this.
Lisa.
I was
Reviewer, you have 2 minutes to explain.
Hello everyone, my name is Wu Xiaoqi from King Amateur, and today I will review the problem number 4 color line. And here is the problem statement. And we'll focus on why we can observe a line and the range of the green light angle, and overview of the reporter. They observe a variable color line on the disk and affected by diffraction and incident angle. And the theory is interference and diffraction grating. And the experiment, they check the diffraction angle and the incident angle. And the process, they investigate, stick to a problem statement, and clearly control the angle of the incident and the diffraction angle, and the concept no main focus on the green line, and didn't explain the phenomenon clearly, and didn't consider the difference between CD and DVD. And overview of the opponent, and they discuss about the reflection and the grating and the formula, and the process ask nice question to reporter and discuss the formula clearly and discuss the theory details. And the concept didn't focus on the range of the green line, and didn't focus the CD thickness or CD's the plastic on it, and it didn't focus on the experiment. And the topic of the discussion, the opponent asks, do you think the reflection is the reason to see the green line? And the opponent didn't say her opinions, and our own opinion is no, it's diffraction and incident angle. And why can we observe a line on the disk, not the shape? And the reported opinion is detect the color on the spectrum and compare with the color diagram. And okay, and this is I asked how did he define the green that he can see, and he detect the color on the spectrum and compare with the color diagram. And okay, and do you think when you stand in a different position, the line will be not straight like the red? And the opponent said the first statement is the equal color line. So, but I mean, okay, and I mean, when we stand in a different view angle and we can see the line on the disk, it will not be straight. It will like that. Okay. And the missing point, they didn't discuss the experiment, and the reporters say the reflection and grating is not important, but we think that is very important. And I mean the shape. I asked why it's not a shape, and the opponent said it's the first statement tell me to observe the line, but I asked why it will not be the plane. Okay, and thank you for your attention.
So in our later discussion, okay. So first on the you say talk about is the line is linear or not linear. Is in fact I indeed didn't mention it in when we are doing experiment, but we just focus on the angle and the color change in the spectrum. And the result of CD and DVD will be different, since in the formula we know that the track width is not the same as in CD and DVD, and this just affects a lot. And in the experiment, we just define a green line with wavelength and color card. But we use we define as in wavelength just in general, just like what most people think that is green line, and we just use the wavelength region, and the color part is for a reference to make sure that it's right. Okay, so that's it.
Questions from the viewers? Any questions?
I have a question for the reviewer. Why do you mention that the light will not be the light won't go straight?
Because the experiment, the video they show is a little bit like it's not a straight from different angle. We see it's a little bit like that.
Which part can you point out?
Just like
I think is I didn't know the real reason, but I think it's
It's very.
it's like it's not very straight. It's a little bit.
Oh, that's why you said.
Other questions?
Yeah, and then I would like to go further. And then how do you think about that?
They look not straight, but it's not straight, but here to here and here to here is straight.
Oh.
So I think and can you play again?
oh, this
That is white area. It's a reflection, and I think it's the area, right? It's the area, yes. But I think it's not colored line because it's only the reflection from the light bulb.
about the same
About
question.
why she said the light is not go straight.
I agree with what opponent has.
You agree with her?
Yeah, is that here is linear, but there are the slight angles and that I cannot explain. Sorry.
Oh. Well,
Further questions?
I just.
Of course, I think but I think maybe it's affected by the angle we have just saved the record.
Other questions? I have one question. You mentioned that your grating separation is 1400 nanometer. Where did you get that number?
What the what?
The grating separation. In your A, you say 1400 nanometer. Where did you get that number?
Just the CD just when
Where did you get that number? 1400.
you say
Your A equals 1400. Yes.
so
Where
just
did you get that number?
on the CDs on all the layers.
Did you verify it?
No.
Okay, thank you. Further questions? If no, then please finalize the scores. 5, 5, 6, 7, 7. Score for the 6, 7, 7, 6, 8. Then the score for the reviewer. 7, 7, 6, 6, 6. Okay. Again, not too much variation. So, do we have any comments from the jurors? Yes,
I'd like
please.
to say that I think the reporter has sort of reinterpreted the question. That's why I'm not giving things like
Okay.
the other ways. I mean, you are free to explore more than the question demands, but you should first explain clearly what the question asks about.
Okay.
I think
All right. Do we have other comments? Okay. Now then, thank you very much.